Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So in the last video, we talked about LSTM network, that how it deals with the problem of vanishing gradient. And then we did a small project on that. So in this video, we are going to talk about autoencoders and its few applications. So this is going to be an easy topic for you given that you have already watched my previous videos, especially lecture on neural network. Because autoencoders are just like neural network and you will know why. So before we talk about the autoencoders, let's first talk about traditional neural networks and its training. So here we have a neural network. So this network has input layer, then we have one hidden layer, and finally we have output layer, and it classifies the images of cats and dogs. So if we give the image of a cat, it classifies it as a cat. Next, I would like to talk about the training phase, like how neural network trains. So we feed the image, then it predicts whether it's a cat or dog. Then it's check the actual label and the prediction. And based on that, the losses are calculated. Then these losses are back propagated through the network in order to minimize these losses so that the model can achieve a good accuracy. And this is something keeps on happening till the time we want or we feel that we have achieved the good accuracy. So this was a very quick introduction to how neural network works and how they are trained. And if you want to know more about it, I have already uploaded a video on that, and also I have a blog post on that. So now let's change the scenario a little bit. So now what we have done here, instead of cats and dogs label, we place the same photo as an output and train the whole network again. So now my question to you is that what would happen in this scenario? I would suggest you to pause the video and think for a while and try to come up with your own explanation. So if your answer is that the network will learn to duplicate the image, then you are absolutely right. And if you didn't get the answer, don't worry about it. We all are here to learn something. So this network will learn to produce the same image as an output. So now we are getting there. We are getting closer to autoencoder. So here we have another neural network that has this kind of structure, and it is going to do the same thing, trying to recreate the image. So if you observe here that the network has a very different kind of structure. First, the number of neurons in each layer is decreasing, that it is increasing. So what is this? What type of network is this? Any guesses? So this is our autoencoders. And now we know what they do. They try to recreate the information, and in this case, they try to recreate the cat image. So what is an autoencoder? So it's a simple neural network with particular design policy. And what is this policy? That we will talk in later part of the video. So they are class of semi-supervised algorithm because during the training we sometimes use historical data with correct label. However, during the actual use of autoencoders, we won't be able to use the previous evaluation matrix, or in this case, RMSE. It is designed in such a way that it can reproduce the same data that we have seen in the example. We just have to put the same data as an output during the training. So some of the use cases of autoencoders are dimensionality reduction and removing noise from the data that we will do in practical section as well. So let's talk about the design policy and training. So first thing that you will notice that in most cases, the network contains odd number of layer if you count the input layer. In our case, it is 3, and it is not mandatory. This is something that I have observed from different sources. So this network can be divided into two parts. First is encoder and second is decoder. So what does encoder do? It encodes the information or compress the information in the middle layer. Next part is decoder that decodes the information from the middle layer to reproduce the same output. Then it compares the output with the original input, and based on that the losses are computed, and then these losses are backpropagated through the network, and accordingly weights are updated. And if you are wondering about the math, it is similar to neural network where we have activation function, bias, loss, and backpropagation. So let's understand this with an example. Suppose you and your best friends are playing a game in which your friend creates a riddle related to some event of past that you guys shared together and writes it down on paper and give it to you. And your task is to decode the riddle and tell him about that particular event. If you decode it correctly, then there will be the next riddle. And if you don't, your friend will explain you the riddle and then you will move on to the next riddle. If you haven't played this game and it is your first time, you will fail miserably for the first few tries. After some tries, you will start decoding the riddle easily. So the more you guys play, the better you will get. So what is happening here? Over a period of time, you are able to decode the same information that your friend encoded. And that's what autoencoder do. Again, this is a very simplified example, but I feel this example sets the intuition right for the autoencoders. And here I have drawn these two figures side by side to show the similarity between these two processes. So I hope this example make you understand the idea behind autoencoder. So once you have the idea, then math is not going to be tough for you. Even if you know the working and maths behind neural network, that is sufficient. At the end of the day, autoencoders are nothing just densely connected neural network with a particular design policy. And yes, don't forget to read about the original paper on autoencoders. So next we are going to talk about different types of autoencoders. Although there are 5 to 6 types of autoencoder, but in this video I have only talked about 3 autoencoders. So the first autoencoders we are going to talk about is a sparse autoencoder. So here we have this sparse autoencoder. So in this type of autoencoder we have more number of neurons than the input layer, and the reason for that is we want to extract more number of feature from the data. But there is a problem with this kind of network. So due to this design, what can happen? It can cheat or they fit the data without learning much. It will just copy paste the feature without learning much during the training process. Since it will be easy for the autoencoder to do so because it has more number of neurons to accommodate. It will just copy paste the weight or do something like that. So the best way to deal with this thing is to introduce the sparsity in the network, and this is why we call it sparse autoencoder. So it is a type of autoencoder where the number of neurons in the hidden layer is greater than the input layer, with a regularization technique applied in order to introduce the sparsity in the autoencoder. So regularization technique means a technique that helps avoid overfitting the model. So this regularization technique puts some constraint on the loss function. That is something you can read in paper, which does not allow the network to utilize its all the hidden nodes at the same time. So during the training, some of the neurons won't be firing up and some of the neurons will be firing up. So here we have more accurate representation of sparse autoencoder. And if you have been following this lecture series, you know what it is. This is called dropout, where we deliberately switch off specified number of neurons in a layer. So if we talk about this particular case, at this instant, the network is using only 3 neurons out of all the available neurons in the hidden layer. So in the next iteration, some other nodes will be participating, and this keeps on happening during the training process. So in nutshell, we are training all the hidden nodes, but not at the same time. So this allows the network to extract feature without overfitting by taking the different combination of neurons in the hidden layer. And that's the whole idea behind sparse autoencoders. Next, I want to talk about Denoise autoencoder. So a Denoise autoencoder is a modification on a sparse autoencoder to prevent the network learning the identity function. Specifically, if the autoencoder is too big, then it can just learn the data, so the output equals to the input, and does not perform any useful representation, learning, or dimensionality reduction. Denoise autoencoder solves the problem by corrupting the data or introducing noise on purpose. And in the practical section, we will create an autoencoder that will remove noise from the data. So now let's understand the training of the denoise autoencoder. So during the training, we introduce a noise layer in the network, as you can see from the data. So we feed the image, then the noise is introduced, and after passing through this layer, data become noisy. Then this noisy data is fed to the autoencoder and it gives some output. And this output is being compared to the actual image, the image that does not contain any noise. So this keeps on happening throughout the training process. And at the end of the training, our autoencoder learns to deal with the noisy data. Note that sometime I'm saying data or sometime I'm saying images. So don't get confused with these terms, because in most of the deep learning tasks, image is the data. So you can consider both the same thing. Next, we are going to talk about stack autoencoder. So this is very simple. This is going to be very simple for you if you understood the idea behind autoencoder and you know how neural network works. It is just that we have multiple layer of neurons and the structure is like this, that we are reducing the number of neurons in each layer, but after some point we are increasing the number of neurons. So it's just mirroring itself. So this autoencoder is very good at reducing the dimensionality in the data. And in practical section, we will see that how we can reduce the data using stack autoencoder. So you can see that the working is quite similar in all the autoencoders. It is just that we are tweaking things here and there, and just like that, we have different kind of autoencoder. Like if we introduce sparsity in the network, we have a sparse autoencoder. If we introduce noise layer, we have denoise autoencoder. So if you understood the idea behind autoencoder, you won't have much problem understanding other types of autoencoder. So that's all I have to talk about this topic. So if you are new to the channel, don't forget to subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, stay safe and wear a mask.